Now in this lecture, in this session, we'll discuss something which is called as eye diagram. So eye diagram is an important tool in communication engineering, which is basically used at the receiver to know various impairments in the communication channel. So what are the different impairment of communication channel that can be seen using eye diagram? So extent of noise, distortion, optimum sampling extent of timing jitter, immunity to noise, timing jitter. These are the parameters that can be evaluated just looking at the eye diagram. It is to be noted that the eye diagram is not a diagram of like a biological eye, rather it is a pattern which is obtained in CRO. So how to obtain that pattern in CRO, and what does it tell about different parameters? That is something we are going to discuss here. So first of all, to obtain the eye diagram, what we need to do is, number one, we need to apply pulses at the channel output. That is, the output of the channel, the pulses at the output of the channel need to be applied at the vertical plate of CRO. Number one. Number two, and we have to set the CRO time base at a rate 1 by TB, that is RB. That is, what is the meaning of this? So we are basically adjusting the sweep in such a manner that the pulses every TB duration will overlap. Pulses every TB duration will overlap. So we will get overlapping pattern of successive TB pulses. And let us see with an example. Consider this is a pulse which is received at the receiver side. Now this pulse, it is assumed that channel is ideal in nature. That is why the pulse is without any noise and distortion, very distinctive pulse. So in this case, how to make the eye diagram? So first of all, corresponding to 1, this will come TB, this duration is TB duration, and then corresponding to 0 minus V will come, so it is like this. Then corresponding to 1, again it will overlap here, then again corresponding to 1, this will overlap here, and corresponding to 0, this will overlap here, and so on. So this is the eye diagram that we will get, and which is shown here. So we can have this duration is TB, and this duration, if we choose time base at 1 by TB, then we will get this diagram, and if we choose the time base 2 TB, then the eye diagram that we will get is something like this. So it is like this window. So this total is your 2 TB, and if we choose this time base as TB, then we'll get this eye diagram. So this is for a ideal channel case. Now what if this is for ideal channel case, and for the case when your pulses are rectangular in nature? However, it is not necessary that pulses are always rectangular. There are cases in which we are transmitting these pulses, as we have seen in the case of raised cosine spectrum. So if my pulse is like this, then with the same line of argument, my eye diagram will be like this. But in both the cases, case 1 and case 2, I have assumed that channel is ideal in nature, that is, it is devoid of any noise and distortion. Now this is a case 3. In case 3, you can see that in bit duration, this is bit duration, my signal is a different signal. The signal which is received at the receiver is a different signal. It is expanded signal. So this case, that is case 3, is basically a case of ISI plus noise. Mainly it is a case of ISI. So in that case, how eye diagram look like? So in this case, my eye diagram will look like this. So what is happening is, so this is my first this thing, so I'll draw this first, then I have my this thing, so I'll draw my line this first, then from here it will go like this, so from here it will go like this, and then from here it will go like this, so it will go like this. So repeating this way, I will come across a structure like this. So it is very clear that if I look at the case 1, case 2 and case 3, so case 1 and case 2 are corresponding to channel which are ideal in nature, and case 3 is a channel which is dispersive channel, that is channel which is with ISI. So you can see that in case 1 and case 2 eye is wide open, however in case 3 eye is closing. So the one of the important parameter which is clear from this example is that whenever channel is noisy, channel is dispersive, then the eye will tend to close as shown in case 3. However, so in other words, the extent of dispersiveness can be seen from the closure of the eye. More is the closure of the eye, more will be the ISI, more is the opening of eye, less will be the ISI. So more opening, maximum opening, no ISI, is a less opening, there is effect of ISI. So this is one of the important parameter which is clear from this. Now what are the other parameter which we can see from eye diagram? To understand this, we have drawn a typical eye diagram. So this is a typical eye diagram. In this case, we have assumed that my pulse is, the pulse which I am transmitting is like this, and the eye diagram, we will try to understand various parameter that can be evaluated from this eye diagram. So the parameter that can be seen from the eye diagram is, the first is your zero crossing. So this zero crossing, this is a point at which, this is a level after which, a level at which it is crossing the zero. So this is a reference line. This is one of the parameters that can be seen from the eye diagram. And the second point is maximum eye opening, that that can be seen from this. What is this? This is a maximum eye opening. What is the maximum eye opening? What does it indicate? It basically indicate the immunity. So immunity against noise. Now how does it indicate the immunity against noise? Actually this is my optimum sampling instant, because at this instant my amplitude is maximum, my level of the pulse is maximum. That is why the effect of the noise will be minimum at this sampling instant. So the maximum eye opening indicate the immunity against the noise, as is indicated here. That is, if I have an eye with the less eye opening, and then I have an eye with a more eye opening, in the second case it will have more immunity as compared to the first case. And this particular parameter 3 is, it indicate, if someone gives you the eye diagram, then you can easily say that this is the point at which we must sample, because at this point your eye is wide open and the immunity is maximum. That is why this is the optimum sampling instant. Next important parameter is your slope of eye. It indicates immunity to sampling time jitter. Now where is the slope of eye? This is a slope, you can see. So if I draw this is also a slope. So this is, say this is case 1 and I say this is case 2. So my question is, in which case does the system will have more immunity against timing jitter? Now, or sampling timing jitter, or sampling jitter simply. What is sampling jitter? Where should I sample? I should sample this, because this is the optimum sampling instant. But what if I sample here because of sampling jitter? In this case, Now if my I is this, in this case what is going to happen is the amplitude is less, however in this case amplitude is more. In other words, if my eye is closing slowly as in the case 2, then the system will have more immunity against sampling jitter as compared to the case 1. This is another important parameter that can be seen from the eye diagram. Third important parameter is your this 0.5, that is level crossing jitter. So what is level crossing jitter? If you see this, then now this is basically at this instant in this region we don't know, we know that levels are crossing or zero crossing is happening, but what exactly, where exactly the zero crossing is happening is not clear because of this width, so this is a jitter which is called as a level crossing jitter, and this causes an error and it should be as less as possible. So for example, if I consider this case, if my eye diagram is this way, if my eye diagram is this way, okay, now in this case level crossing here is at this particular instant, so there is no jitter. However, in this case there is a jitter, so wider is this region, wider will be the level crossing jitter. And the next important parameter is a 0.6. 0.6 is your error free sampling region. So this particular region from here till there is error free. Why? Because in this region your amplitude either in positive or negative is above 0, so that is your error free sampling region. And so these are the parameter. And one more parameter that we have seen, that if eye is wide open, the effect of ISI is less. If there is a closure in the eye, then effect of ISI will be more. So these are the parameter that we can see from the eye diagram. So if we again, eye diagram is an important tool to know different parameters. What you need to do is apply your pulses at the output of the channel to your vertical plate, and then you apply, you set your CRO time base at the rate 1 by TB, that is RB, then you will see something which is called as eye diagram.